is Sam Richard, a developer advocate for Chrome OS, progressive web apps, and web capabilities at Google, and Snugug throughout the internet. And today, I'm going to talk to you about progressive web apps, their past, their present, and their future. The story of PWAs starts with the story of HTML5. The first working draft of HTML5, then known as Web Applications 1.0, was released on September 1st, 2005. For context, that's almost 18 months before the first iPhone was released, over 3 years before Android was released, and over 4 years before the terms mobile-first and responsive web design were coined. Before all of that, there was this draft, this thought of what the web could be. The first sentence of its abstract sums up its intention. This specification introduces features to HTML and the DOM that ease the authoring of web-based applications. Applications. That was the vision for HTML5. That vision, put forth September 1st, 2005, that the web could and should be a place for applications, not just documents, was a powerful one. A vision we're still trying to fulfill. But this was 2005. In a few short years, the world the web lived in was going to change out from everyone's feet. A true paradigm shift, if ever there was one, moving from desktop to mobile, was about to unfold. But this idea, that the web could be a place for applications, proved strong enough to withstand the shifting sands of computing. Even more than that, it would show the need for the web to make this shift. But that's getting ahead of the story. The web, up until the introduction of HTML5, was designed to be used online, a series of connected documents. With applications as a major driving factor for HTML5, there became a need for web applications to work offline. In May of 2007, Google introduced an open source browser extension, Google Gears, designed to help make web apps work offline. One of the most frequently requested features for Google's web applications is the ability to use them offline. Unfortunately, today's web browsers lack some fundamental building blocks necessary to make offline web applications a reality. In other words, we found we needed to add a few new gears to the web machinery before we could get our applications to run offline. Aaron and Eric from Going Offline with Google Gears. While not a web standard itself, it was built on top of web standards, adding just enough AJAX to make current web applications work offline, with the goal of evolving it into a set of web standards. Gears included a number of components that may sound familiar to you today: an SQLite-powered database, a local server that could cache and serve resources, and a way to create desktop shortcuts. While Gears would officially be deprecated in March of 2011 in favor of web standards that had finally caught up, as you'll see, its influence is pretty hard to miss. The earliest draft of the HTML5 spec I can find that mentions offline web applications comes from October 2007. A subsequent draft sums up the capabilities that HTML5 provides to help applications work offline: client-side SQL, online and offline events, local storage, and finally, offline application caching APIs, later known as Application Cache or simply App Cache. App Cache was a big deal. For the first time, there was a standards-based way of telling a web browser that certain assets, your CSS, your images, your HTML, should be made available to a user when they're offline. App Cache was entirely declarative. You created a cache manifest file, put in the specific files you wanted the browser to cache, and it, through a series of built-in rules, would. The first two browsers that would get full App Cache support were Safari 4 and Firefox 3.5, both released June of 2009. Android Browser 2.1 would get it later that year, then Chrome 4 and Safari on iOS in early 2010. It wouldn't land in Opera until mid-2011 or in Explorer until the end of 2012. App Cache was great in theory, but in practice it had a lot of gotchas. Jake Archibald described why it was so hard to work with it in his A List Apart article, Application Cache is a Douchebag. A few key, painful ones mentioned include files cached with the app cache would always come from the app cache, even if the user was online. The app cache would only update if the content of the manifest file had changed, not if the content of the things cached changed. And non-cached resources wouldn't load on cached pages, even when online, by design. Replacing app cache was the start of a new chapter towards what we know as PWAs, But before we get there, we need to take a detour to what the web looked like on desktop at the time. From conversations with members of the Chrome team who were there at the time, what we know today as progressive web apps started life back in 2010. At the time, there were two competing schools of thought for how to make the web a better app platform. One school of thought was to work with the standards process and improve the core platform. The other school of thought was that the standards process wasn't fast enough for the features they wanted to deliver. The group that wanted to work through the standards process, led by Alex Russell, Dmitry Glazkov, and Alex Komorowski, went on to propose or drive web standards, including mutation observers, HTML templates, object observe, web components, ES modules, ES classes, CSS variables, web animations, just to name a few. The group that wanted to work faster than the platform created Chrome Apps. Launched December of 2010, Chrome Apps' goal is something you've likely heard from a number of similar solutions, from Electron to Cordova to even progressive web apps today. Build fully featured applications that just happen to be built with web technology. Packaged Chrome Apps may sound familiar to you PWA developers out there. They could be launched from outside of Chrome, got their own app windows, and could generally behave like other apps. They were offline by default. Resources required to run offline came with the app, and it included APIs to make the page resilient under poor network conditions. And there were new APIs added to gain low-level hardware access, for instance to USB and Bluetooth, and new shared data APIs to let it more easily interoperate with other applications on the system. Chrome Apps also introduced Native Client, or NACL, and its siblings, allowing web apps to run C and C++ code in the browser, and allowing a migration path for existing code bases, while also offering better performance than could be achieved with JavaScript alone. What these two teams learned and developed during this time would become indispensable as people took another pass at web apps and getting them to work offline. In August of 2012, a group of developers and browser vendors came together to talk about App Cache. First in London, hosted by FT Labs, then in Mountain View, hosted by Mozilla. Their goal? Talk about practical experiences with sites that developers were presently building. Facebook, Gmail, the Financial Times, and The Economist, Twitter, and Microsoft Outlook were among the participants. The conclusion? Not quite tear it all down, but pretty close. In June of 2013, the Extensible Web Manifesto was published. Remember that group I mentioned that wanted to improve the web through the standards process? One of their leads, Alex Russell, would help write this Extensible Web Manifesto. It solidified many of the lessons he learned in that previous work. The authors of the manifesto had seen that, with high-level abstractions, users either needed to buy into the entire thing or replace it entirely with an alternative. They believed that users should instead be able to take control only at the points they needed to accomplish the job they wanted. With this in mind, the manifest offers 4 design principles for an extensible web. Focus on adding new low-level capabilities that are secure and efficient. Expose low-level capabilities that explain existing features, allowing authors to understand and replicate them. Create a virtuous cycle between standards and developers by developing, describing, and testing new high-level features in JavaScript, and allowing developers to iterate them on before they become standardized. And then finally, prioritize efforts that follow these recommendations and deprioritize and refocus those that don't. The first commits for what would become the service worker spec were laid down by Alex Russell in February of 2013, and by the time the first public working draft was published on May 8, 2014, the service worker spec was a shining example of the Extensible Web Manifesto in practice. Where App Cache provided a high-level declarative syntax for caching and then had its own rules for deciding what to serve, service workers and the sibling Cache Storage API were low-level APIs that allowed users to script what should happen with JavaScript. Using both, service workers and the Cache Storage API, users could describe, then recreate, how browsers handled caching and how App Cache handled caching. Chrome 45, released September 2015, was the first browser with full support for both the Cache Storage API and service workers. Firefox 44 and Samsung Internet would get support in 2016, followed by Safari 11.1 and Microsoft Edge in 2018. By the end of 2020, some 13 years after it was first described, App Cache has been officially deprecated and removed from Chrome, Edge, Opera, and Firefox. Service workers and working offline is only part of the progressive web app story. Getting onto the home screen required something else. When the iPhone originally launched in 2007, it didn't have the App Store. The original iPhone came with standard apps, Safari 3.1, and the ability to make special website bookmarks, known as web clips, which would add a website to the user's home screen. Then, on July 10, 2008, just over 2 months before Android was launched, Apple released the App Store and fundamentally changed how people thought about software. Where to find it, how to buy it, what it should cost, and what their relationship with it was. As it turned out, software development, especially on the web, was going through not one but two paradigm shifts. The move from desktop to mobile, and the move of app discovery from search engines to app stores. The web, though, had no app model at a point in time when the conversation around software development centered on apps. The result? Uncertainty that the web would survive the tectonic shifts happening. By the time the web had an answer, it had seemingly already lost. Building on trends of multiple years of data, the Comscore 2015 mobile app report painted a stark picture of web usage on phones. Users spent just 13% of their time on mobile devices and browsers. The rest was in apps. Apps were eating the world. But apps are tough business. While the majority of time was spent in apps, comparing the top 1,000 mobile web properties versus the top 1,000 apps, the web had audiences 2.5 times larger, and they grew twice as fast. That said, while it was harder to build an app audience, app users spent 18 times more time in their apps than mobile web visitors did on sites. Apps also seem to be a zero-sum game, with 4 to 5 smartphone app minutes being spent on an individual's top 3 apps. Tablets, even more so. The big takeaways Comscore had from this data were that it's easier to build a larger audience on the web quicker because of the web's superpower, linking. While web app usage was exploding, that wasn't at the expense of mobile web or desktop, so they believed the key growth opportunity was in multi-platform engagement. Finally, app usage is a reflexive, habitual behavior, where those occupying the best home screen real estate were used the most frequently. The web at this point had already more or less one desktop for most use cases, and it was already easier to build a larger audience faster on the web than apps. Linking and a single shared platform across mobile and desktop meant distribution on the web was much easier. What was the web missing to stay competitive with mobile apps? It lacked an app model. The 2015 Comscore mobile app report came about at just the right time, as the pieces needed to let a site be added to a user's home screen were finally falling into place. The missing piece to the app model puzzle came December 17, 2013, with the publication of the first working draft of Manifest for Web Apps and Bookmarks. This spec, now known as Web Application Manifest, was initially written by Marcos Caceres from Mozilla, Anis Kostianen, and Kenneth R. Christensen from Intel. It was designed to consolidate metadata about a web app, like name, icons, and URL to open when launched, from various meta tags into a single place. Its goal? To enhance bookmarking capabilities, such as being able to add a web application to the home screen of a device. On mobile devices, Chrome would add support to add web apps to the home screen in Chrome 39, November of 2014. Samsung 4 would follow in 2016, with Safari 11.3 in 2018. Between working offline and web application manifests, including key features like start URL and icons, the web now had installation criteria for adding a website to the home screen. That criteria hasn't changed much since. But it didn't have a name. They were just installable web apps. On June 15, 2015, Alex Rustle and his partner Francis would coin the term progressive web app to describe web apps that were as reliable as, and could be installed like, mobile apps. A normal website that, when built well and earns its place on your home screen, could progressively become an app. The name stuck. Halfway through 2015, all of the pieces were in place for an app model for the web. It had service workers to allow sites to work offline or with limited connectivity. It had the web app manifest to describe how an installed site should function. And it had a name, Progressive Web Apps. It was only a matter of time before one existed. The first PWA I can recall, and maybe the first one you can too, is the Air Horner, released by Paul Kinlan midway through 2015. While fun, it's mostly a demo. Or it may be the Google I/O 2015 site, which was probably the first large-scale PWA, and whose development motivated the creation of SW Precache and SW Toolkit, what would go on to become Workbox. But the world's first production PWA is generally considered to be Flipkart Lite by Indian e-commerce company Flipkart, released November 9, 2015. Introducing their PWA had a dramatic effect on their user engagement. A key metric for Flipkart at the time was tracking data usage to complete first transaction. When comparing Flipkart Lite to the mobile app, Flipkart Lite used 3 times less data. This was especially important as 63% of Flipkart Lite users were on a 2G network. Service workers and the low friction of the web's distribution model combined to make these possible. Getting Flipkart Lite onto the home screen was important too. 60% of all visits came from launching from the home screen, and those users converted 70% more than the average user. Those 2 activities alone grew overall engagement 40% higher than it was before. Flipkart proved that PWAs could compete with mobile apps when installed, but e-commerce is a space where web apps were already good at. To be a truly competitive platform on mobile, the web needed to be able to take on platform apps on their home turf. By design, the web is less capable than platform apps. Its drive-by nature makes exposing many APIs and features a security risk. But when the web is capable of delivering a particular experience, it can compete. Linking and the lack of gatekeepers give the web a better distribution model than app stores. A change in PWA installation paved the way to closing this capabilities gap. The initial implementation of PWAs on Android was by design minimal. Basically, they were glorified home screen shortcuts. They didn't show up in the app drawer, they didn't show up in the app switcher, they didn't really feel like apps, besides having a home screen icon. On Android, the base unit of administration for an app is an APK, or Android Application Package. The APK is how Android deals with things like notifications, running in the background, targeting for sharing, backup and restoration, and more. After the successful launch of Flipkart Lite and momentum behind PWA started to build, the initial implementation's lack of integration needed to be fixed. On May 10, 2016, the first CL for web APKs was merged into Chromium. Web APKs were a big deal for how progressive web apps would evolve. Dominic Eng, a lead for progressive web apps at Google, shared that web APKs really built the foundation of the deep system integration that we've pursued ever since. That deep system integration started life as Project Fizz. Project Fizz, named to complement Gin, an early codename for Chrome, had been around since 2014, not as a formal team, but as a collection of teams within Google, with the goals of bringing top requested APIs to the open web, creating infrastructure that enables new capabilities to be experimented with and exposed in risk-limiting ways, and optionally enabling web apps to receive the same UI treatment and integration as mobile and desktop apps. Fizz was responsible for a lot of early PWA work, including service workers, background sync, and push notifications, enabled with the availability of web APKs. They also introduced Web Bluetooth, first available in Chrome 56, released January 2017, and Web USB, first available Chrome 61, released September 2017, as the first 2 new powerful APIs, specifically designed to close the app gap. Fizz would evolve into Project Fugu and the current Capabilities project, pretty much keeping the same mission and focusing on bringing these new APIs to browsers. It also moved beyond Google to a cross-company effort, including significant contributions from Microsoft and Intel. When progressive web apps were first launched, they were originally envisioned only for mobile devices, as a way of helping them compete with mobile apps. But the web is more than mobile. The benefits of PWAs extend not just to home screens, but to taskbars too. By allowing PWAs to be installed on desktop devices, the promise of write once, install everywhere could be fulfilled. Prior to PWAs coming to desktops, Chrome had something called Bookmark Apps. Built on the foundations laid by Chrome apps, Bookmark Apps, so called because they were something between a bookmark and an app, were what was created if you added a site to your desktop. In 2018, when Chrome started working on bringing true progressive web apps to desktops, the implementation was forked from these Bookmark Apps. Rollout of desktop PWAs started with Chrome OS version 67, released May 2018. Take another 3 releases to Chrome 70, released October 2018, to add Windows and Linux support. and yet another 3 releases to Chrome 73 on March 2019 for Mac to get support. Much like on mobile, desktop PWAs from the start proved that websites could earn their place on taskbars, often without much effort. At Google I/O 2019, Hulu shared their story of creating a desktop PWA to replace a legacy Windows app they had. Just like ComScore said about mobile back in 2015, Hulu reiterated that even though the legacy app had poor reviews and lacked features, users kept using it because it was ever present, just a single tap or click away. They started small with a simple offline fallback service worker and a manifest file, just enough to make their replacement installable. It took one developer 2 weeks to build, QA, and release their new experience. That was one sprint for their team, literally the fastest they could possibly deliver results. In the 3 months since their launch, they saw 96% of their legacy app users adopt the new PWA, and compared to their website, saw a 27% increase in return visits and a 5.5% increase in engagement. Desktop PWAs would come to Edge 79 January of 2020. And that brings us to today. PWAs are here, can be installed on any device with a web browser, and there's lots of work going into making them even more capable, letting the web compete more and more with desktop and mobile apps. The Capabilities Project has launched 30 new APIs between Chrome 71 and 91, including expanded hardware support with WebHID, WebSerial, and WebNFC, deeper OS integration with file system access, a contact picker API, and WebShare and WebShare Target, and has even expanded what installed PWAs are capable of with the badging API and app shortcuts. Modern meta frameworks, including Next for React, Nuxt for Vue, and SvelteKit for Svelte, all have built-in or officially supported extensions for creating PWAs, often with 0 config options. There are developer tools like Lighthouse that can be used to test if your website meets installation criteria, and more, including as part of your CI/CD process. There are libraries like Workbox to help you build and maintain your service workers, allowing you to quickly implement and leverage common caching and serving patterns. And there are tools like Bubble Wrap and those powered by it like PWA Builder to simplify the process of bundling your app for distribution and into stores. Speaking of stores, Google Play, the Microsoft Store, and Samsung Galaxy Store all support listing PWAs, letting them take part in the App Store discovery, preview, and review ecosystem. In fact, on Chrome OS, both Twitter's and Pinterest's PWA experiences are so good that they've both replaced their Android apps in the Chrome OS Play Store with their PWAs. And Clipchamp, an in-browser video editor that had never been available in app stores before, saw their PWA installation rate increase by 97% a month in their first 5 months after upgrading to a PWA and getting listed in the Chrome OS Play Store, with PWA users having a 9% higher retention rate than standard desktop users. Their video editor, it also got an overhaul, moving from Knackle to WebAssembly. Clipchamp's success with PWAs isn't unique. On mobile, from a May 2021 case study, Mainline Menswear, a UK-based online clothing retailer, saw a 55% increase in conversion rate with their PWA versus their mobile site, along with a 12.5% higher average order value and 243% higher revenue per session. From a June 2021 case study, Blibli, an e-commerce marketplace in Indonesia, found their PWA generates 10 times more revenue per user than their previous mobile site, reduces bounce rate by 42%, and shows an 8 times improvement in mobile conversion rate. And from a May 2021 case study, Orange Polska SA, a leading telecommunication service in Poland, saw a 52% increase in conversion rate for their PWA versus their previous mobile site, along with 30% faster average loading times and an 18% increase in session depth. On desktop, we're seeing the same thing. From a December 2020 blog post, Capwing, an online image, video, and GIF editing platform, saw that within the first 5 weeks of launching their PWA-ified website, the number of people creating videos through their PWA grew 36%, outpacing overall website growth and indicating a higher retention rate among creators who installed the PWA. And from a December 2020 case study, Corel Corporation's Gravit Designer Pro, a powerful vector design tool that also offers Windows, Mac, and Linux apps, saw PWA users are 24% more active than any other install type, a account for 31% more repeat users than other platforms, and are 2.5 times more likely to purchase Grab It Pro. Over the past 6 years, we've learned a lot about what it takes to build a successful PWA. When they were first introduced, PWAs were about push notifications, working offline, and being installable on phones. There was a push to make your whole site work offline, and an app shell model that favored single-page apps and refactors was encouraged. But today, we know that any way you want to build your site, single-page or multi-page app, as a static or a dynamic one, are all great options for building your PWA. We've seen that even minimal work, adding a custom offline page in a web app manifest to make a site installable, produces big results without needing to re-architect your site, add lots of features, or ensure everything works offline. And we've learned that, basically outside chat and social networks, basically no one likes push notifications. We've seen total PWA installations per day increase by 769% year over year. Today, it's no longer a question of if you can or should you make your site a PWA. It's a question of why haven't you yet? But maybe that's not fair. Sure, making a website installable is now easier than ever, and there are benefits from even that little bit of work. But is it enough? When the web is capable of delivering a particular experience, it can compete. So I ask you, take a moment to think about it. What's holding your work back from being able to compete? What's the web you want? For me, I think this is the future of progressive web apps. Taking that thought of the web as an application platform from the first draft of HTML5 all the way back in 2005 and making it a reality. PWAs can and should mean more than an installable website that doesn't crash when offline. PWAs should be the lens through which we view the web as the only truly universal application platform. Create once, deploy everywhere. One code base, one team, one skill set. Building one app that's installable, reliable, and capable, regardless of what device a user chooses to access it from. To get there, we need to get better at delivering more experiences, and there are some experiences where the web doesn't compete well today. App discovery on the web isn't great. For better or worse, many users expect to find, preview, and review apps from an app store. Some users find curated stores like Google's Play Store or Apple's App Store a more trustworthy way to find apps than just a web search. App stores also have built-in monetization tools that the web lacks. Upcoming APIs like the Digital Goods API, coupled with the Payment Request API, are looking to make a dent on this for the web, but it's still a tough, not yet solved problem. And packaging is still a problem. How can we install a PWA without an initial network connection? Is it possible to provide an installer for PWAs like desktop apps traditionally have? And how can we trust the contents of those packages? And then there are capabilities. This, I think more than anything else, is the story of the future of progressive web apps. The web as an application platform is not going away. It's only growing. And to compete, we need to expand what the web's capable of doing. Work is being done today to let installed PWAs register as file handlers, URL handlers, and register as protocol handlers. There's work being done to enable new data transport options, give more control over PWA app windows, access local fonts, and use the browser's built-in media codecs. There's even work being done to enable enterprise use cases, like reading device attributes and establishing custom TCP/UDP connections. Developer feedback is what drives these new capabilities, and your feedback is critical. So I ask again, what's holding you back from being able to compete? What does the web need to succeed as an application platform? Think about it, then share your thoughts with browser vendors, in their issue queues, in comments on web specs, and through webwewant.fyi. Together, we can make the web a truly unique and amazing application platform. Special thanks to these individuals for helping fill in the history of PWAs from their unique perspective of those who were there at the time. Thank you all very much.